Hello. Oops, sorry. So, hello to everyone. That again, we'll wait a few more minutes, and then we'll start. So I see we are 5 in total. If I recall correctly, 15 people, with me included, were registered in this meet. You can hear me, right? Okay. Let's wait a few more minutes, like until 5 past, to see if anyone else joins, and then we'll go straight to the presentation. Okay, so it's 5 past, so I'm not sure if anyone will join, but if they will join, I don't think we should wait longer. So thank you all for joining. Fix this. Okay, so thank you all for joining. My name is Michail Yarmakopoulos, and this is the first general meetup of the user group, the Spanish user group in Barcelona of APL. And this will be a general introduction to APL and its history, its current situation, and future, well, the prospects it has, applications, and I'll do also some live coding examples to see how this language works in practice. So I'm not muted, right? Okay, all right, thank you. Also, thanks for anyone that joined that don't live in Europe. I know our difference might be a bit difficult, but I appreciate that you joined. So let's start. A little bit about me. My name, well, the official name is Michail, but the Greek name, the unofficial, is Michalis. Other friends call me Mike. Most non-Greeks call me Mike because it's easier than Mikhail or Michail, as they call it. They read it in Spain. So I'm a Greek living in Barcelona. This is the banner of the football team from Patras, where I've spent most of my years. And so, yeah, Barcelona. I'm not a football person, but I thought, what the hell. And I have a physics and mathematics background. I did the bachelor's at the University of Crete in physics and master's in mathematics and computational mathematics at the University of Patras. And then I worked for a few years in a startup called Incivio, bioinformatics startup. And then I moved to Barcelona, where I work as a data engineer, providing support on very well-known cloud provider. So I'm a cat father. That's mostly because of my girlfriend that picked up the cat from the streets. So this is Leros. This is his favorite table. He really enjoys sleeping there and chilling. And I like reading books about mathematics, informatics, maybe philosophy sometimes as well. So that's about me. And let's go about this talk. Yeah, I will start with, since this is the first meetup of this group, I'll just share my thoughts about the goals, the kind of meetups, and how they will be online or in real life. And then I'll do the history review of APL and array languages family. Then we'll go in the live coding, and well, then if you have any questions, or if you have any questions during the talk, you can ask me or Adam, who's from Dialogue, and maybe he can help you with any questions I cannot. So, and then I have some references you can look up. This slide will be shared in the page of the group and on the GitHub page as well. And then I have to thank some people that were very helpful so far. So yeah, I found this meme. I think it's very, very interesting. But 3 of the array languages, how which language user sees everyone else. And yeah, I find it very funny. This group has pretty much 4 goals. The first one is to spread the knowledge of APL and the array family of programming languages, and then spread the knowledge about Ken Iverson's work and the other people involved in the development of APL and J and K. And actually, I'm mostly currently interested in. Oh yeah, they might be in Africa. Sure. So yeah, I'm currently mostly interested in APL and J, but I am not planning to ban the rest of the array languages in our meetups or discussions or study groups have in mind. So also the third part, to share knowledge related to the intersection of mathematics and programming, because I'm really interested in both fields. And the fourth, which is I think it's the most important, that will create a safe environment where the first 3 points can flourish, is to foster and create a friendly community for people interested in array programming. So yeah, we want to be friendly with each other and make everyone feel like at home. So the next one. So yeah, so the meetups I have, how I have thought about it, will be the general meetups like today's meetup, which will be online and real life. I will explain later why we'll have both online and real life. And I'm thinking of the general meetups to be more introductory and more general, to spread the knowledge of APL and the array languages in the society, pretty much the Spanish society, or more general, in a broad audience. So they can be, of course, technical, but I believe that we should also have beginners, let's say, talks like today's talk. And then I have an idea of creating reading groups where we gather around and we pick like an APL paper or J paper or some other array language paper. We read it either on our own a bit or together, and we discuss then the ideas expressed in that paper. And yeah, pretty much understanding the ideas of, I believe that reading previous literature of APLs and Js, we can understand more deeply how the languages work. And yeah, I personally, like the previous 3-4 weeks that I've been reading about APL mostly, I've seen that there's a lot of material out there from the past, from the 70s mostly, and maybe 80s or 90s as well, that have very, very deep ideas and could also show that the future of APL, J, and the other languages. And the third idea I have is a general reading group where we won't be let's say, bounded in the APL community papers or books, but we can read more general papers about science or maths and books about computer science that could interest some people. So yeah, I think creating some reading groups would be really nice for people that share common interests. Because as Connor has also experience in that, because as far as I know, he has a really interesting meetup where they gather and discuss very important computer science books. Yeah, I was thinking to do some similar like that, but in European time zones, pretty much. And about the online and real life distinction, the two reasons for the online meets. Well, currently it's the virus situation. I think it's safer if we do them online, and also it will be, the meetups also will be more accessible for people that want to join all over Europe, Spain, the world, pretty much. Whoever can join. I mean, if it's not 3 a.m. for them. And well, the reasons for the real life meets that I have thought so far are, well, I have the idea that it will be a very good idea to establish a strong APL JK community in Spain, based in Barcelona. And then, well, in Barcelona, at least, I haven't lived or traveled much in Spain, but we have cervezas, beers, which means beers, tapas, which are like small breads with cheese or salami on top, and chupitos are the shots. So I think I have some pictures there. Yeah, some beers, some cervezas, and some plates of tapas and pinchos. So well, I think that online meets are good, but they cannot. But in real life, communication and interaction is much more powerful. I'm sold. Okay. Yeah. So yeah, I think let's hope that the thing with the virus will go away as soon as possible, and we can start also on in real life meets as well. Okay. So the past is pretty strong past, or it has many aspects, many players. So Ken Iverson on top left, with Falkov, they worked, and Ken wrote a book called The Programming Language. As far as I read, they were thinking about the name, and Falkov came with the name A Programming Language, and beneath he wrote APL. So before that, they were referring it as it. Pretty much before the first implementation of the first interpreter by the engineers, which I believe they're some of the people in the picture on the right, top right. This language was pretty much a notation, mathematical notation that was consistent in expressing mathematical ideas. That was Ken's original vision, as far as I have understood. And then Ken at that time was working in Harvard, and he moved to IBM, where Falkov was, and I think a big milestone was the IBM system /360 that ran APL. And then most of the important players left IBM and went to IB Sharp Associates. And I have the name of Ken's son, Eric, who went to IB Sharp before Ken went. And so then there was APL2, then Dialog APL came, and then, well, this is a very big, very short summary of history. There is a very nice paper by Roger Huey and Morten from Dialog that have wrote the history of FPL from 1978, I think. I have it in the references in the end. It's a very interesting read, and it has all the information that I want share today. So Whitney, who I think was working at IB Sharp as well, left IB Sharp, and I think he went to a company like Morgan Stanley, and there he created A and A+, and then later he created K, which commercial product right today. And the second project of Ken with Roger. Roger is on bottom left. Well, bottom right is Whitney, and I think it's Arthur. And Roger is on top, on bottom left. So Ken and Roger created J, which was much thought of as the APL, the next APL. And so there is a very large connection between APL and J. I personally had encountered J in the past, which was the first language of both that I had experience with. I think it was 2005. I don't remember how I found it, but I don't know, I was bored and I found it. I thought it's very interesting, although a bit esoteric for me at the time. So I played with it for a few years and then I stopped. And so a lot of new ideas and like a lot of improvements of APL have been done in J. And well, the difference is that although APL has these weird symbols, which we call them glyphs, and J uses, instead of the character set of APL, ASCII characters. So this is a big difference, but besides that, they're both in the APL family and very close brothers, I would say. So then, yes, K came, and there are many other languages that I've put in the main page of the Meet that I won't discuss in big detail. But so in the past, this is the first slide. I've put some books here, and well, the first book, I put a link. You can download it. I think the second one as well, and you can find some Amazon links for this too. So this is the book that Ken wrote, which pretty much started everything. And then you can see that there are some applications: mathematics, college of mathematics, mathematics classroom, mathematical accent, abstract algebra, statistics. There's a book about an APL compiler, which was from the 80s, this book, I think. And we'll get back to the compiler thingy later. And there are some more books in more languages. So the first two are from Ken. You can download them. They're very introductory, and I've tested most of the code in Dialogues APL and works. So there are two books in French and some books in Russian, one in German. So this Physics in APL2 is a short book by Gregory Chaitin. He's a pretty famous computer scientist, mathematician who's worked in complexity, I think, computational complexity, and he found like a number, omega. He has done a lot of research about it, and he used the APL back then in the 80s to. So you can download this book. But the code doesn't work with Dialog APL. You have to fix that. Haven't yet. So he used it for computational physics. He did a bit of modeling with Newtonian gravity, Einstein's general relativity, and then he solved, I think, one-dimensional Schrödinger equation, and then Feynman path integrals. And then in the end, I have put the link to Jay's page where they have a lot of books. Some of them have been written by Ken, which are like introductions to mathematics with J, like calculus, algebra, many things. And there's a J for C programmers. It's very a lot of material, actually. They're very interesting stuff. And well, today we have like a summary of the situation of the environment of the array languages family. Dialog APL is at version 18, and 18.2 is beta version. J has two versions, 9.02 and 9.03, which is beta. K has version 9. There's also GNU APL, which is version 1.8, but I don't know how active this project is. There is also BQN, which is I would say it's an APL language as well, which uses symbols like APLs, but has some new symbols as well. So I would say that it's closer to APL than J. JMA APL, there's another APL, NEAL, there are another array language, KAP, NARS 2000, and NGN APL. I might have left a few out of here, a few array languages, but they should be in the main page of the Meet. So on the right, I've put some links. So APL Wiki is a very nice Wikipedia specialized in APL languages and array languages, and it's supported by the community, and it has very interesting material there. You can learn a lot of things there. And this link on the top right is a very nice book written by I remember the name, the pseudonym XPQZ. Adam, do you remember the name?
His name is Stefan Kruger.
Yeah, sorry. Yeah, thank you. So Stefan has created a really nice book about the Dialog APL, and it's online. It's free. You can read it. It's really nice. You should. And there is a Mastering Dialog APL, which is a massive book. If you want to go in depth in Dialog APL, there is a Discord community server where you can find everyone who's interested in these languages. And that's where I met everyone actually with Discord. I found it in the Reddit r/APLJK subreddit. And APL.chat is a chat room in Stack Overflow that Adam has created, as far as I know. And it's really nice as well. Most of the people that are in Discord are also in APL.chat. And tryapl.org is online interpreter. You can run it from your browser that runs Dialog APL. And then there's a Dialog APL vocabulary that I will show it to you because it's really nice. I have it actually. Yeah, so I have it here, yeah. So this has all the glyphs of APL pretty much, explanations, links as well to the documentation of Dialog APL. And you can see it says which one is a function, which is a monadic operator, dyadic, an array. It has more than one roles, and it's a control glyph. So it's very, very nice. And if we go back now, slideshow. So yeah, okay. And then ArrayCast, where this is a very nice podcast on array languages that Connor has created, and there are many important figures of APL community go and talk about the past and the present and the future of APL. So everyone that has done anything important in APL or J has talked there. It's very interesting, and you learn a lot actually by listening to this podcast. I really love them. So the future, I believe it's very right for APL and array languages. So I've made a collection of things that I think that should be mentioned. So Code Defense is a project by Aaron, who created in his PhD, I believe, an APL compiler that runs also on GPUs. So it's a very interesting project, I believe, and it shows a good direction that APL can take. And then Dialog APL, according to my opinion, is the most active dialogue APL and interpreter that exists right now. And I believe that they do great work in spreading the knowledge of APL and giving incentives. Well, the competitions I mentioned below, there are many, but there are some that are being organized by Dialogue that I think are very cool and very important. And there are also APL conferences. There is a dialogue user conference every year, where everyone that uses dialogue or wants to learn about dialogue can gather and learn a lot. So J software is a very active language and very important project in the APL family. And pretty much ideas from J go to Dialogue APL and the other way around. So I really like that there's a communication between and a fertility actually in this family of languages, and ideas flow from one language to the other and they evolve. So if you don't change, you don't evolve, you die. So I like that things are changing and evolving. And there is K, which is commercial, and I think it's very highly used as well. And then there's BQN, which is the language that we mentioned earlier. And then there are many other array languages. I've mentioned some in the previous slide. I'll put a link here in Wikipedia, but you can find in APL Wiki as well, I believe, most of them. And the APL competitions. So I've put a link to the student competition actually from Dialogue. I'm not sure if there are more. I'll have to look and maybe update the slides later. And the conferences, there are a lot. I've put a link to APL Wiki. Also the user groups. There are some, most of them in Europe, and also there is one in Japan. And then applications, right? What you can do with APL. Well, you can create simple web apps. I have put a presentation here where you can call like a HTML code from APL and create a pop-up window that shows some HTML render code. And then there's the Pineapple, which is a very important and very interesting project, according to my opinion, of course, which pretty much is a library that connects Python libraries with APL. So you can call from Python, a Python script, you can call APL. You can run APL code from within Python, and then you can run Python code from within APL, which is really cool. And I believe it's very promising as well. And so I've put here a paper that's an example of computational science with APL. So Chachadi is a French scientist that has used APL, Dialogue APL mostly, for his physics simulations. And this is a paper where he gives some examples, but I have to warn you, this is in French. So I don't know, maybe you can Google translate it and get the general ideas. And then teaching mathematics with APL and J. I've put an example book here that you can download, College Mathematics. And also I've put a link to the link of J software books, where it has many books. I think 4 or 5 of them were written by Ken. And they pretty much introduce you in mathematics and college mathematics, calculus, algebra, or combinatorics as well with J, which is really nice. And then there is some activity with neural networks with APL, Dialogue APL. I think Roger from Dialogue has done some work. He has some videos on YouTube, and also there are some other presentations that you can find them in this link. And oh, I've done a mistake here. Sorry. have this twice. So yeah, I think this should be the question marks. It's 3 times 5, it's 10, 15, so 3, 3, 3. Yeah, so this is, I just copy pasted. So live coding, let's see some examples I have prepared. And do you have any questions so far before we jump to the live coding? Okay, I guess not. So please bear with me, the more experienced. It's very simple stuff, but for those that haven't seen the language before, I think they will show something. So there is something we do when we. So this is the interpreter of a dialogue, APL, and well, the most simple is to enter a number and get a number. And what we usually do, we change the index origin. So the number where the index starts in arrays, because by default it starts from 1. So we change it. I know it's not very nice, but we have to do it usually if we want to use the C style, or Python style, where the array starts from 0. So what can you do? What you can do addition, right? 1 plus 2, 3, simple stuff. 2 times, so multiplication is this x. There are shortcuts for every glyph, so you can either use the mouse, or you can use, you see here it says control and dash. So I use control dash and gives me the times. And we have also the division, right? So 1 divided by 3, 0 through 3. And we have also the power. So 2 to the power of 3, I'm sorry, the power of 3. So power is the star, the asterisk, shift 8, that is 8. Okay, let's see how we can do some things with arrays. So this is an array, and I know some will love this example. I think Morten's it's the first code he saw. So if you add this, pretty much this addition, as far as you see from the example, it adds pairwise. So it's a vector addition or array addition, pretty much. Likewise, we can do multiplication and division. So let's do that. Multiplication, right? Times 4, 5, 6. So it's 4 times 1 is 4, 2 times 5 is 10, and 3 times 6 is 18. And let's see the division. It should be used. I believe. Oh, okay, not that bad. So 1/4, 2/5, and 3/6. Yeah. I think we can also do the power. Yeah. Sorry. 6. Yeah. So we want to check. Right. Well, 1 the 4th. This is silly. I'll do, but 2 in the 5th, and 3 in the 6th. All right, so we can do these operations. Another important operation is the reduce. So if you do, let's say we want to add all the numbers in an array, but let's see how we name an array. Okay, so we want to name A with 1, 2, 3. That's how we do it. We use the arrow that shows that directs to the left. And if we write I, this is it. And let's say now we want to add all the numbers. Well, if we have only 3, we can say, of course, this, right? Well, what happens if we have like 100 numbers or 1,000? It's pretty tedious to use the plus sign. So there's a smarter way. we use plus and slash, which is the reduce, and then you write a. So it's the same. And let's say that we want to solve the problem that Gauss solved when he was 5 or something like that, or 10, I don't know. His teacher told them to add up all the numbers until 100 on paper, right? So we know that he found an ingenious method to do it faster than the other kids, but we can't do it faster than Gauss as well. So there's a way. There is this iota, actually, Greek iota, which let's see what does. If we do iota 10, it generates all numbers from 0 to 9. Okay, so we want all the numbers from 1 to 100, but we'll start from 0. So 100, we'll stop 99. Let's go 101. All right, and we want the addition. Iota 101. So this is the result Gauss found, and we found it, I think, faster than him. So well, reduction, we can do other operations for reduction. So if we want to multiply instead of add all the numbers, let's see, it's the same. You just change the operation. I'll have some chat. Yeah, he did. He was. He was. And so let's multiply the first, the first 10 numbers, and then we'll multiply the first 100. Oh yeah, it's 0. Oh, and yeah, index of origins is a pain, I think. I don't know if I should change it back to 1 to do this example. Maybe I'll do it. Yeah, I'll do it. So we can go a bit up. Okay. Okay, right, all right. So if we do this, it multiplies the first 10. So this is actually the factorial, right? So we can do the same this way, and we get the same number. And if we want to divide, we'll go like that, but I'm not sure what means. I mean, 1 is divided by 2, then it's divided by 3, then it's divided by 4. It's like that, I guess. So yeah, and then you can do the power as well. And then we get a domain error because I did some stupid apparently.
Oh, it's not stupid. It's just very, very big.
Oh, okay. 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 Yeah. Maybe it will do until 3 or yeah. Okay. So it reached infinity, I guess. Let's see, 5. Yeah, 1 plus. I forgot about 1 plus. And yeah, it's big. Yeah.
Well, I mean, you will always give 1, but until it gives 1, it becomes a very big number, right? Because it's 1 to the power of a very, very large number.
Yeah, 2, 3, 4. Actually, I would like to do something like that. Yeah, which is 10 to the 24th. So if we do 5, 6, 7. Yeah, it goes out of the limits of the interpreter pretty much. Okay. So factorials use origin 1, 2. Yeah, alternate product. Okay, so we have a vector. Let's create a second vector, and We can see also how we can create functions. Well, the most usual method is to use omega and alpha. So omega is used to denote the variables on the right of the object, and alpha the variables on the left. So let's see an example where we calculate the average, the arithmetic, the average of a vector, which is the average, right? It's the sum divided by the length of it. But how do we get the length of a vector? So there is this character, which is called tally, and it returns pretty much the length of a vector, or a matrix, no, a vector actually. And so we want you to find the average. So A and divide by tally. And will this work? Or should I put parentheses? Well, I will put them for sure. So it's 6 divided by 3, it's 2. Okay, it works correctly. And so let's define it average, right? So when you define a function, you use the curly braces. So we have only omega because we have only one thing. So we have the plus slash omega, and then divide by tally, which is control, and this just use it from here, omega again. So I'm still learning APL, so I cannot pretend that I know everything, right? First of all, the interpreter reads from right to left, which is different from many languages that we know. And so this might not work as it should. Let's see, average. Hey, okay, it works. So we don't need the parentheses. If we do the average, we'll see, I think that has a function. And then I think if we do boxing tree, Adam, how do we get a tree?
Do dash t equals 3.
Dash tree.
No, yeah, no space.
Okay.
Oh no space after the dash. Make a space here.
Okay.
The other way. It's like a flag on the command line.
Oh yeah.
Dash 3 equals not 3. Dash t equals 3. 3, yeah, like that.
Okay.
It's not going to make a difference for you, really.
Oh yeah, I thought it would show the tree beneath of the.
But it's not going to show a tree because it's not a tacit function. It's a simple function.
Oh, okay, right.
Also, you need to turn it on, by the way. You didn't.
The boxing.
Yes.
Yeah.
Oh, you can just box on or click the button.
I don't know about buttons. Sorry.
There's a button next to where it says the font name. It says APL 385.
Oh, font name. Okay.
Yeah, there's to the right. There, just past it on the left of the back.
This one.
Click that.
Okay. Yeah.
Now it will show the.
But I should do it. Yeah. Okay. To see the tree, you have to do the tacit form. So what Adam said about tacit form, there is a way where you can create a function where you take out the variables like the omegas and the alphas, and it looks a bit more maybe confusing for the beginners, but it's more clean pretty much. So this is how it is, I think. And then I think it's tally and should work. Okay. Yeah, so yeah. So if this is the arithmetic mean, if we want to calculate the geometric mean. So geometric mean, what happened, how it works, where you have the sums, you have multiplication, and where you have division, you have a root. So in our case, it will be the product of the three numbers raised to the third root. So let's see how we can do it, and I'll write it down. Jamie for geometric mean. Let's do it with the first way, and we'll multiply it times omega division, and then we have, so the square root is 1 over the root, so it should be 1/3. And the third, we want to create a general function, so we don't want to hard code the 3. So we will do it like tally and the omega. This should create, so this should give, so A is 1 to 3, right? So 1 to 3. So it should give 3, and then, sorry, I put divided. I shouldn't put divided. I should put power. So it should be power. Yeah. So it's 1 to 3. So it's the 3 factorial to the power of 1/3. 1/3. Let's see if the geometric mean gives the same, and it doesn't. So 6 to the power.
I think you have the same issue as you had before with the average function. You need to compute the product first and then raise it to the power of 1 over the length.
Because it goes from right to left, right?
Yeah. Same thing with your average function above is giving the right result, but for the wrong reason. It should be the sum divided by the length, not the sum of all the elements divided by the length. Which mathematically comes out the same, but here it will come in and bite you because it's not the same.
Okay, so if I put parentheses, will it fix the issue or? No. So you say that I should do first the multiplication and then I do the power. So
oh, but you're right. Hold on. This does give the same even mathematically, right? Because it's the product and the power is a repeated product, so it's the same. Yeah. Sure.
So yeah, I did something with the factorial, I think, before. So I think if I do it like this, it should give the same result. Yeah. Yeah. So what it did here, it did a division, and then it raised 3 to the power of 1/3, and then it took the factorial. I think we did that. But I'm not sure if we can take factorials of floats. We can. Okay, that's interesting.
It's not really a factorial. It's a gamma function.
Yeah, but it's interesting that it uses gamma function beneath. I didn't know that. All right, so what else can we do? Well, I have prepared some stuff. Let's see what we've done so far. Well, operations, multiplications, vectors. Oh yeah, well, we haven't seen the row thing. And also the random, how to take random numbers, which is cool stuff. So, or the mem, how to create a matrix. So let's say we want to create a matrix, a 2x2 matrix with all the numbers from 0 to 3. How do we do it? With the 2 to row and then iota 4. Yeah. So what the row thing does in this case, as you can guess, it creates a 2x2 matrix out of an array of length 4. So iota 4 is pretty much this array, and then if you put the row behind it without nothing, it just gives the dimension on how many elements it has. But if you put on the left 2 numbers, it creates an array, a matrix. Sorry. So well, we will see some operations with matrix. We can, of course, we can multiply, and we can add matrix together. Matrices. Let's create one more, and well, I'll create the same. Yes, I can do that. Yeah. So b plus a, yeah, and b times a. Okay, so the times when it's applied in matrices, it's not like matrix multiplication, is it? Let's see. Okay, so we have A and we have B, right? Oh, okay, then they're the same. So B times A, it's matrix multiplication. All right, my bad. And yeah, okay. But this is the inner product, right, Adam?
It's the same thing. Mathematicians, for some reason, insist on calling it by 3 or 4 different names, but it's the same operation.
Okay.
It's summation over the paired up transposed multiplication.
Okay. All right, so let's, I think we have an array here. We don't have an array here. Let's create one new array, 4, 5, 6. And also let's create the dot product or the inner product, which is what Adam wrote in the chat. So if we want to create the inner product of 2 arrays, right, we'll do that. It does be, and it should be also the same because it's commutative operation. So what this means, so what we did, we added the pairwise product of the vector, so it's the same like that. And what else can we do in respect with linear algebra? Let's say we have, let's say we want to solve a linear system, right? We have, so this is how do we write comments. We have the system, we have a matrix A, then we have a vector X, and then we have a, well, just do it in capitals, caps X, B, and we want to find X. But let's do it a bit more simply. Let's say we want to solve this equation. So find the array or the matrix X, or if when it's multiplied with A, will give the same matrix. So there is a glyph, which is this one, domino. So if you use it with the same matrix, you get a solution. So if we say we have B, this one, and we want to, I'm not sure if I can do it like we would do in algebra, or I should make the array like a one-dimensional matrix, like a column, but I will try. It's that hard, failing. Yeah, so have the length error, all right, and yeah, What is this you wrote, Adam?
Comma bar makes a vector into a column vector.
Thanks. Comma bar. Okay. So this one should do be to how we want. Oops. Oh, that's great. So B column, let's say B column is this applied on B. All right. Okay, so we want to solve the linear system AX equals B pretty much. So the solution should be A. So this is the inverse actually of the matrix. So if we do this A, this gives the inverse of the A matrix. So if we apply the inverse on B or on B or B on the inverse, it should give X. And let's do B inverse A. So mathematically, what I would do, I would multiply AX equals B from the left with the inverse of A, right? And you will get X equals inverse of A that acts on B. But given that APL parses from left, right to left, I think I'm wrong. So A B column BC C inverse A and then fails, okay, and then BC inverse A dot BC and then fails. C dot is our dot product. This is ridiculous. Apologies.
You have the
more
arguments in the wrong order. It's just A,
yeah.
Matrix division BC.
Oh, okay. A matrix division. This one.
What is A? What size is A?
It's 2 by 2.
Well, then you can't do it with 3.
Oh yeah, it's 3. Yeah, yeah, yeah. B2 is, let's say 1, 2, and then B2 C is is 2 C. So A divides B2 C. All right, and let's name this C actually, or X, and let's see if it solves actually the solution of the system. So right, so this is X. So if you go to the system above, A times X should be, so if we multiply A with X, yeah, with inverse X actually, with A with times column X, I think. Inner product maybe. A X A dot column X. Yeah, I love live presentations. Everything goes as planned. So what we're trying to do is to see if X that we found gives B if you multiply it with A. So we saw that A is this two-by-two matrix. And All right, so x, we saw that
You just want it on the left, no? Just x plus dot times a, or ax dot a.
So it's a 2 by 2, and then I have to, yeah, you're right. I have to put on the left the x because its dimensions is 1 by 2. So I should do x dot, and this is b, b2. What is it? B to C. No, B to C is 1, 2. So x times a. No, B2. So B2 is 1, 2, and A is this one, and X is this one. And we should get B2 when we multiply A with X. So we see the row gives that X is 1 by 2, so which means one row and 2 columns. And for this reason, it should go on the left of A because A is 2 by 2. So we remember from linear algebra that we have to go 1 by 2 times 2 by 2, and this will give 1 by 2 array, which will be B. But it gives 0.8 and 1.4, where it should give 1 and 2.
No, but that's pretty close, isn't it?
I was expecting, the exact values, shouldn't we?
But if you have the two variables, you're saying that 0 times a plus 1 times b equals 1. And 1 times a plus 3 times b equals 2. Right? Then, so what that means, b equals 1. So if b, sorry.
Yeah, sure.
We can solve this by hand. So if b equals 1, then in the bottom you have 3. So 3 plus 2a equals 2. Right? Or 2a plus 3 equals 2. So you subtract 3 on both sides. That gives us -1 on the right. So that means a is -1/2. Should be, so this should be -1/2 and 1.
But B is 1 and 2. So I don't know. Well, I did an example earlier and it worked, and that's why I'm surprised it doesn't give the exact numbers.
We messed up something.
Yeah, I think I did something wrong somewhere. So yeah, let's do it again. So we have A, we have B and 2, and we have B to C, and we want to find X. Okay. So we use the division operator here, domino operator, it's called as well. We divide A by B, and this should give X. So if we divide A with B, B2. Okay. All right. So this is it, actually. This is X. Okay. So X is A divided by B2.
But it's not right. Right? It's here. Do like this. You have B2, you called this? Okay. B.
Yeah, sorry.
Okay, so you can just write like this. B2 and you have A. So B2 matrix divided by A.
Okay, B2 matrix divided by A.
And there you go. That's your solution. And now you can take this.
So this is X. B2 divided by A. And now if I take X and multiply it with A, so it should be.
So you write A plus A dot, or A plus dot times.
Plus
dot.
Sorry, plus dot times, yeah.
And then that solution, yeah.
Yeah, so which is B, right? So if we do.
You can't do that. On the other side.
The other, yeah. Oh yeah, of course. The order of the operations. This should give true. So true. Sorry. No, maybe not this one. Maybe the equal under bar.
It's B2, no?
Yeah, that's why I didn't like it. So 1 is for true and 0 is for false in APL. So for example, if let's see the true and false, we saw it. We saw that B2 is this one. Let's say if we equal 1 equals B2, so it gives the positions where it actually gives a truth array, right? True and false, because 1 is true for the first position of B2 and it's false for 2. So this is how you solve a linear system. So what we were getting actually, Adam, when we were doing A divided by B2 instead of B2 divided by A?
Mathematically speaking, not sure.
Yeah, this is weird. It gives an example, a result, and doesn't say something wrong.
It's an overdetermined system. It gives you the least squares product for the least squares solution to the overdetermined system, I guess.
Yeah.
So
okay, so you can do much more than I've shown so far. I don't know if anyone from the audience has any questions or would like to see some other calculations with APL, or if you have any other general questions you'd like to ask. Well, I can show you something else. We have something in the chat. Okay. Oh yeah, I have a slide for after the questions. Yeah, it's a really nice slide, so I should use it. Sorry. Oh yeah. Yeah. Where is the slideshow? And so yeah, I found some nice pictures. So this is the first one with Fry from Futurama. This is very fitting. And one, so this one as well, no questions. And I've put one more in case I had a lot, not that many. So yeah, I've put a lot of material. So the first one is the link of the meet. Yeah, tapas, yeah, sure. I know a very nice bar restaurant near my house actually that has very nice tapas. Next time I will go, I'll put some more pictures, maybe online or in the meet, to lure you in Barcelona for tapas and beer. And so this is the APL wiki link, which has tons of information about the APL and the array languages, the try-APL.org, Wikipedia about APL wiki about CAN, the papers of CAN, Roger Hui from APL wiki, his papers, some various APL papers and J papers and J software link, and some French papers I found very interesting. I was very curious if anyone was using APL for physics. I wasn't taught actually APL in the physics school, and so this person, this doctor actually Chichati, has used his research APL for quantum mechanics stuff. It's pretty interesting. And also here's the book of Chaitin with some code he wrote in the 80s, and he says that APL fits for physics because it uses matrices. So it's very fitting tool. And then I have a few more. So these 3 books from Ken about teaching, math teaching actually, and math teachers, and a few examples for scientists and engineers. So here in this 16th link, I found the examples of how to solve a linear system. And this is a paper I told you earlier about APL since 1978, which is really good read. And this is the link about the program language of CAN. Some more links about CAN, adding BM System 360. The page, the image with APL developers, history of APL, the page of J, this paper. So this is, I think, so CAN was awarded from ACM with a Turing Award, I think, 1979. And this, I think, this speech he gave notation as a tool of thought. Yeah. And so the page of J, IP Sharp, scientific time sharing corporation, which was another company at the time, K, Arthur Whitney, we, Roger. And I would like to thank here Adam for all his help and for helping this meet and for answering all the questions I had so far while I've been learning APL. And O'Connor for his awesome work and his YouTube channel, and of course for his Arraycast podcast, and also Dialogue for supporting this meet and spreading it around in their LinkedIn, Facebook, and also being very helpful, and for promoting APL all over the world. And last but not least, the APL JK community that was very friendly and welcoming for noobs like me who don't have much knowledge in computing, but are very interested in learning as much as possible. And I think that's the last slide. So the tapas, I'll show you. So this is my favorite tapas shop, bar near my house, actually. Show you some pictures. Has maps. Where's the maps? So it's called Aitor, which, funnily enough, the name is from Basque. It's Basque, from Basque country, but the owners are French. So, but they're very nice people and very welcoming. And you can see some pictures here of food and drink. So this is, I think, fish, and here's some tapas and some more meats. So they have tapas in like a glass compartment, and you pick it, and they count the toothpicks. They charge you, I think it's 170 per each. And so you have some fish as well. So this is salmon, and this is a paella, which is rice with fish stuff. So yeah, and this is a very famous plate, which is called patatas bravas, which is potatoes in the oven with some sauce on top, spicy sauce. So yeah, hope we will do something in real life as well in Barcelona and have great fun with APL, J, and tapas and beer. Oops, sorry. Where's the presentation? And yeah, so I don't know if you have any questions or comments. We still have like 10 minutes to, if you want, of course, to discuss or to go through some links maybe.
Thank you to you for kicking this off, even if it might start low key. A lot of things
Sorry?
start. I say thank you to you for starting this off, even if it starts low key.
Yeah, I don't
that
mind.
doesn't mean it can't grow.
Yeah. I'll hope it will. I hope it will. But I'm very excited actually. So I had this great idea of creating it. I thought, yeah, I looked in Meetup. It wasn't expensive at all to create a Meetup, so yeah, why not? So yeah, but so links.
We have a question from Jerome whether.
Oh, if I've used APL professionally in previous work environment. No. So mostly I use Python in work. I've used Python in work so far, and So no, professionally, no, I haven't. But for example, Adam uses it professionally daily. And
Yeah, I don't know if it really counts because
any Python APL
no,
wrapper.
if
So
if really counts that I've used APL professionally because I only use APL for the sake of the APL. I don't actually like produce anything in APL.
yeah,
I
well,
guess.
yeah, okay. Well, yeah. You work on the libraries and things, I guess. So Python APL wrapper, no, but I tried to use the pineapple, which is this one. I'll share. Actually, I'll find the GitHub repo. So this one is actually I don't think it's like a wrapper pretty much, but so APL, yeah, dialog I used first J and then dialog APL. And now I'm learning dialog, but I will continue learning J as well, because I think they're both very important. J, well, it actually has very many libraries. Maybe it's more fitted for mathematics and analytics, and yeah, and plots, functions, and so I can share actually this the repo for the Python APL. Adam, I think we have a question for you in the chat.
Which version of APL plus PC?
Yeah, Jerome seems to be using version.
Okay, I think I started with the earliest I had was like version 8 or something like that. I don't know. It's been a while. It wasn't long before I went to APL plus 2. And no, because so Jerome is asking if it was in 5.25-inch floppies, and no, because my father was like on the forefront of computing. So when I was 2 years old, he bought no, not mainframe, no, APL plus PC is for PC. So when I was 2 years old, he bought the best computer that money could buy, an IBM PS2 for $20,000 or something like that. And it came with two 3.5-inch diskette drives, two of them, and it could handle the high density double-sided diskettes and the whole shebang. So so I never really, I mean, yeah, I have worked with 5.25-inch floppies, but only because like he gave me an old computer. How big were the workspaces? So he could have like paid double, I think. No, is that true? Yeah, he could have paid double to have double the RAM. Double, I mean, he could have paid $40,000 instead of $20,000 so that he could have gotten 16 megabyte RAM. No. Yeah, is that true? Yeah, instead of 8. No. Kilobytes. Haha. No, hold on. I can't barely scale these things anymore. No, that sounds right. Right? Yeah, so no, APL plus PC wasn't 32 bits, it was 16 bits. But as I said, I quickly went to APL plus 2, which has its own yeah, so you couldn't have more than you could fit in 640K. But the computers were running with memory extenders at the time. So it was a 386 processor, and I think it had 8 megabytes of RAM, and then it ran a 385 extender or something to, and I'm not sure if APL plus PC could use that extra RAM. I don't know. But APL plus 2 had its own memory handling. It took forever to start up. But then, yeah.
Adam, have you played with new APL at all? Or?
What do you mean new APL?
GNU
Oh,
APL.
GNU APL. I've tried a
Yeah.
little. I tried installing. That didn't work right.
Oh,
Otherwise I used the try GNU APL website for GNU APL.
okay.
Yeah.
Okay.
So yeah, I miss APL plus. Well, not APL plus PC so much. APL plus PC, APL plus 2 were very similar. The difference was nested arrays or not. So the interface, the language, everything was the same. And I miss that. Here we are, whatever it is, 30 years later, and dialogue's interface in many ways has not caught up with the level that APL plus PC was at 30 years ago. So APL plus PC had some really cool stuff. You could trace through an APL program primitive by primitive. So for every
Oh, that's
primitive,
nice.
you could inspect what is the right argument, the left argument, and the result of it, and then go to the next primitive or backtrack. I think you could even. So there were some very nice things it could do.
So you could debug in detail then.
Yeah, it's in the most extreme of detail. I can't get any more detailed
Mm.
than that. That was very nice.
Yeah, sounds
Uh,
very nice indeed.
it also, I mean, Dialog has a possibility to set your F keys so that you can do automated tasks as you develop, but you have to like program them. Whereas in APL Plus, you could record macros on your F keys. That was really, so if you needed to just do something really quickly at other times, you just record a macro and just do it again and again. Oh, APL Plus PC could connect to other remote sessions. That may be. I wouldn't have known. I was just a kid. My father would not have allowed me to connect to other people's computers. Yeah, Arbin, but okay, but Dialog APL also has Arbin and Arbout. I think those are more like standard.
Mm.
I never used it for anything other than taking care of input from the keyboard. But
Adam, do you know, have you seen the dissect tool in J?
yes, I have.
It's really nice, I think. Do you think this could exist for dialogue IPL as well in the
Yeah,
future?
to a certain extent, it kind of does. I mean, one thing that bothers me with it that it can only run when you are running your code to
Oh,
analyze
okay.
what happened. It cannot analyze the code because APL and J are not. It's not possible to statically analyze APL and J code, which is one thing that BQN and K allow.
Oh, okay.
So there's a downside there, and so there's limited what you can dissect in advance, whereas at runtime you can do it. And yeah, I mean, I used it, but I found that it was overwhelming. It wasn't and didn't look so good.
So static analysis has to do with that dialog APL or J don't have a compiler, or is
No,
relevant to that?
it's inherent in the language. It's
Okay, because it's
there's
dynamically
yeah,
typed.
it's too dynamic. So and you cannot predict what things are going to be, then it's impossible to fully analyze what's going to be. That
But
doesn't mean
BQN
you
is
can't.
more strongly typed.
It's nothing to do with types.
Oh,
It's
okay.
it's to do with predictability of what things are and
Okay.
the scope of things. And the BQN has something called roles where you can immediately see on the name of something what its role is. So you can see if something is a function or if it's an operator or if it's an array. Always. And that
Okay.
allows you to parse. But the way APL works with operators and functions, you can't parse it. So you can have an example. If I write A, B, C, A space, B space, C in APL, what does that mean?
A space, how do
A
you say
space,
again?
B space, C.
And A, B, C are arrays, or?
Ah, look at that. The first thing you ask me is, oh, A, B, C, they are arrays? I didn't tell you
Oh,
what they were.
they can be anything,
And you
right?
came and asked me. That's the problem. If you were an analyzer of the code, the first thing you do is error because you don't know what A and B and C are.
Yeah, yeah. It's
That's what I
very
mean.
vague. Yeah, yeah, okay. I get it.
So it's limited how much analysis you can do before. But actually, there's a really cool thing. If you bring up, or I mean, I can share my screen if you want.
Yeah, yeah, sure.
I can something from
Let me stop sharing. Share.
actually I can
Stop share.
just
Stop
take
share.
over.
Yeah, then stop sharing. Okay.
There you go. Okay, so let's say we write a function. Let's say we write a function average. And it is the sum of the argument divided by the max of 1 and the length of the argument. Okay, so there's actually something we can copy in. Copy defense TC. And TC is an operator, monadic operator. So we can stick it in to the right of a function. So this takes the function sum, and this takes the function division, and this takes the function max, and this takes the function tally, like that. Okay, and now when we run average, it prints like this.
Oh.
So it says the tally of this is 5,
that's nice.
and the max of 1 and 5 is 5, and the sum of this is 14. And 14 divided by 5, 2.8. There you go.
It shows the
result.
evaluations.
Exactly. This is very much like dissect, just in a much simpler.
Yeah. More low level. Yeah.
Well, you can do it as high or as low level as you want by inserting and removing the keyword TC. So if I instead of having it here, I put it under here. So now instead of applying it once on the summation, I apply it on the addition.
Yeah.
Now you can see every addition happening separately.
Okay. Yeah.
It's now in it needs to add it. We can also add it here. It will look a little bit funny because TC is part of the function, but so you can see what it's doing here.
Yeah, that's nice to see how it's being evaluated.
Yeah,
that's very nice.
So the first thing, yeah, so inside here is this happening, and the overall application of this gave this. So it's a little bit like dissect. I use this sometimes, but most of the time I'm not really in doubt as to the order things happen. That's not my problem. And so I haven't really needed something like dissect. I'm not sure what maybe if you have a lot of tacit functions, it's more necessary. But I mean, even if I make this tacit, it still works. So just need to get rid of all of this. It'll still be exactly the same. See.
Yeah.
So what might be nice is if there was an automated way to insert TC into everywhere, so you could just switch this tracing on and off. Yeah, sure. Yeah, Peter is saying we've been inserting quad gets everywhere. Yeah, that's when people say like, how do they do that? But there's a lot more you can do. There's also I should share again. Let's say we have a larger
my email address. Yeah, I think I've added. Oh no, yeah, I'll put in the site, but I can share it in the chat.
If I make this a multi-line function instead. So let's say we say sum is this, and the count is this, and then we have the average, which is the sum divided by the count. Let's see. Does this actually work? I'm actually a little bit in doubt because I don't really use this a whole lot. So no, it doesn't work. But let's So let's say we have a list and we have a result. So making it into a traditional function. So a lot of cool kids, they only use defense. They never discover the power of the traditional functions. So here's something you can do. You can set a trace bit, this yellow blob on it, like that. And now what happens when I run it? It prints out a message for every line saying this line evaluated to this.
Okay.
So that corresponds to these trace bits here. So you can selectively choose that. And the good thing about it is it doesn't modify your function. You don't need to insert quad gets or the TC.
So this is a thread FN, right?
Yeah, a thread FN, yeah. And
but
then I can
without the Nebula thing.
You don't need to write that. That's not part of the function. It's only when you define it in the session you need to do that.
Oh,
to
okay.
indicate that your beginning function definition mode and your ending function definition mode. Or if you have a lot of them together in a large script, then you put them around there. But I mean, you can do it. It's not.
Mhm.
It
It's
will
but it's
allow
not
it will allow it,
okay.
but it will also take them away if you auto format because it's not necessary. And the good thing about these is you can selectively do this, and you can let's put this on the side. Then you can clear all of these bits like this. So you can see it's cleared all the trace bits. And you can do it even on the program control. So what I can do is I can say, for example, I can have a debug flag here. So now, so let's start by saying if 900 I-beam just means is it monadic? So if it's monadic, then debug is 0. And then down here, I'm a bit worried about this one, for example. This is where things go bad. So here I can say if debug, then, and then we can say this is where we do the count. So we put a label on the count, for example. So I don't, labels are not traditionally used for go-to statements. We don't want to use those, of course.
Yeah.
But what we can do is we can say count quad trace quasi is the stack indicator, and the first element of the stack indicator is the function on the top of the stack, which is our function. So this is the same thing as AVG, like that. So this says set that yellow blob on the line that's called count,
Mhm.
like that.
I think we have got a question from Peter.
Okay, sorry, I wasn't looking here.
Yeah, sure.
Can I have multi-line type functions in files if I run with that script? If yes, you can if you enable multi-line input. So also, by the way, Mikhail, you send your email address to only to me, even though you intended
I
it to be
did.
to you wrote at, but that does not how the chat works in Zoom.
Oh yeah, I didn't. Yeah, everyone. All right. Yeah.
Yeah, so if you're using Windows, then it's very easy. You go in configure, and then you go in session, and you select multi-line input to do that, and then that gets saved. Otherwise, there's an environment variable which is called dialog line editor mode. I think you set that to 1, and then you can use multi-line anything in the session, because it's a bit experimental, but yeah, eventually it will become. Anyway, so let's try this. And so now if we say AVG here, this just works. And if I turn on debugging, then we can see that it turned on tracing on itself for this line. So you can see what happened. And if we look at the function again, you can see it has turned on the yellow blob. So this is something that's, has upsides and downsides. And a cool thing is that APL is very closely tied with the environment, the development environment. There's no IDE and an interpreter engine. It's one and the same, and you cannot separate them. But it has the benefit that the language itself can have an effect on the development environment. So I can use APL to program my environment.
Okay.
And not a lot of people take advantage of this. They just think that, oh, this whole interactive thing is all annoying. It's in my way. I just want a REPL thing. But it's actually a very powerful thing that I can make it do things very easily. And I can program my environment, especially on the Windows. It's very powerful. So anyway, actually, you should probably here have an else and turn it off otherwise.
So if you do something on the environment, you can save like what you've programmed, right?
Yeah,
the new environment you created.
There's actually it's a binary blob that is the environment. So this might look like a normal application or like an old style APL application, but in fact, all this is APL, or most of it, not everything is. So here, for example, it has a help menu, right? But I can actually say quasi is my session object, and I have a menu bar called MB, and it has an element called help, and help has a property called caption, which is help And the ampersand means that if you use the Alt key, you can hit H to go to help menu like that. See, it's underscored to that. So I can actually
Okay.
change this. So you can see my help menu now is called something else.
Yeah. Oh, okay. So it's wow.
It's
I didn't know
actually
that.
APL, and it means you can do all kinds of cool stuff, right? It has upsides and downsides.
Yeah. I'm sure you can
but-
make it crash and never be able to use it again.
Well, no, you can always rebuild the session and from
Yeah.
scratch.
Yeah.
But it's pretty cool to be able to do things like this, and
Yeah.
you can create editors. So the editor itself is a function.
Mhm.
So I can it comes up on a different screen, but here it opened up an editor. So you can use the editor under program control to do things. It's part of the language.
So the first window is the workspace where you can do anything and create new editors, like the second
Yeah.
one.
It will not allow you to save the workspace while the editors are still open, but yeah, you could.
Yeah. Okay.
You can create them under program control. You can do fun stuff with this.
That's nice. That's nice.
Yep.
All right. So I know it's a bit.
Yeah, it's over
late.
time.
Maybe we can end it here. So thanks, Adam, and everyone who joined. And I'll put the next meeting soon as I think what we'll do then. I have some ideas and I'll work them, and hope to see you soon then.
Bye.
Thanks for joining. Good night. Bye.